Okay, another example here. We will determine the largest interval over which the h of x is equal to x over x squared minus 1 is continuous. Now, for the rational function, it is continuous on the respective domains. So, the only point in which the rational function is discontinuous if its denominator is equal to 0. So we will take the denominator x squared minus 1, which is not equal to 0, or the an equation of inequality, to determine in which the function is discontinuous. So x squared minus 1 must not equal to 0, or x squared must not equal to 1. So we will extract both sides. So x is not equal to negative or positive 1. So x equals negative 1 and positive 1 is the only point in which our function is discontinuous. So it means that our function is continuous on an interval except on the point negative 1 to negative 1 and positive 1. So all values of x is an element of all real numbers. The function is continuous if and only if x is not equal to negative or positive 1. We can write the real number minus the negative 1 and 1, or we could write from negative infinity to negative 1. That's the largest interval. From negative infinity to negative 1, our function is continuous there. And also from negative 1 to 1, our function is also continuous at that point. I mean at that interval, and from 1 to positive infinity. So we could see that we use the parenthesis. We use parenthesis for this one because we must exclude the negative 1 and 1, because x squared, that's negative 1 squared minus 1 is equal to 0. That means that our function is undefined. Same goes for the positive 1. So it is excluded. But that's why we put parenthesis, because our function is continuous from an interval negative infinity up to the value which is the x is lesser than negative 1. And also the same goes from here. We will start from x is greater than 1 to infinity. We should also remember that at the interval from we can verify that on our graph of a function, that from negative infinity to x is lesser than negative 1, our function is continuous, but we stop at x is equal to negative 1, and then we started to the right of x is equal to negative 1. So we could trace our function. It is continuous over on that interval, and we stop again at exactly x is equal to 1. There's an interruption on that at that point, and then we can trace again at x is greater than 1 to positive infinity. So the answer is from negative infinity to negative 1, union from 1 to positive infinity. That's the largest interval. Okay, so determine the largest interval over which our function is continuous. This is a piecewise function, 7 minus 3x if x is lesser or equal to 3, and negative 2 if x is greater than 3. We know that these are polynomial functions. It means that our function is continuous everywhere except in which our pieces meet. So at x is equal to 3, we will evaluate it using the three conditions of a continuity on a point, which is the f of c must exist, the limit of the function must exist, and the f of c must equal to the limit of the function. Now, our x is equal to 3, so our c is equal to 3. We will start at limit of the function. Now, for the limit of the function, we will evaluate the limit on the left side and the limit of the right side of the function. Okay, so for the left side, it means that a function or equation which is lesser than the value of 3, which is 7 minus 3x, and for the right side, that means the x is greater than 3, which is the second equation, or negative 2. For the left side, limit of p of x as x approaches c minus is equal to a limit of 7 minus 3x as x approaches 3 minus, so that's 7 minus 3 times 3, so 7 minus 9 is equal to negative 2. For the right side, limit of negative 2 as x approaches 3 plus, so that's negative 2 as well. Since our limit in the left side is equal to the limit of the right side, therefore, our limit of the function is equal to negative 2. How about the f of c or the p of c for this case? So the p of c is equal to what? The first equation, which is, we will use this, is if x is equal to 3. Now our x here is 3. So 7 minus 3x. So 7 minus 3x, that's 7 minus 3 times 3 is equal to negative 2. So our f of x or p of c is equal to negative 2. Now, for the third condition, our f of c must equal to the limit of the function. So the p of c here is negative 2, which is also equal to the limit of the function. Therefore, our function is continuous at x is equal to 3. That also means that our function is continuous everywhere included at x is equal to 3. So the answer, the largest interval, is this one, all values of x, which is an element of all real numbers, or from negative infinity to positive infinity.